right, welcome to section 10.2.3. We're now going to start talking about combinations. So in this lesson, in the previous lesson, you learned a method for counting arrangements or permutations. In this lesson, you will consider questions such as how many 5-card poker hands are possible, how many spirit committees can be selected from the junior class, or the chance of winning the lottery. In a 5-card poker hand, the arrangement of the cards does not matter. Since all the spirit committee members have equal status, the order in which they are selected does not matter. If you have a winning lottery ticket, you will not care about the order in which the numbers are drawn. In these situations, you need to count the combinations. So, for example 1 here, it says 5 members of the spirit committee have volunteered for the club governing board. These members are Al, Barbara, Carl, Dale, and Ernie. The club members will select 3 of the 5 as board members for the next year. One way to do this is to select a governing committee in which all members would have the same title. In a second way would be to select a president, vice president, and secretary. Part A says how many different lineups of officers are possible. This means president, vice president, and secretary are chosen. Al is president, Barbara is vice president, Carl is secretary is a different possibility from Al, president, Barbara, secretary, and Carl, vice president. So, how many ways are there to do this? Well, again, we can use, since the order matters and you can't repeat, this would be a permutation. So we can either use a decision chart or a permutation. So there's 5 people that could be president, 4 people vice president, and 3 possible people secretary, which would be a total of 60 different ways that we could do this. Part B says how many different governing committees are possible. In this case, it is a good idea to make a list of all the possibilities, which are called combinations. So, if we think about this in terms of grouping of people, not necessarily the order, we would have Al, Barbara, Carl as one group. We could then have Al, Barbara, and Dale as another group, and Al, Barbara, and Ernie as a third group. We could then get rid of Barbara and do Al, Carl, Dale, and Al, Carl, Ernie. We could then get rid of Barbara and Carl and do Al, Dale, and Ernie. So this is all the possibility of groupings with Al in it. And then I could go to the ones without Al. So I could do Barbara, Carl, Dale, Barbara, Carl, and Ernie. And then I could get rid of Carl and do Barbara, Dale, and Ernie. And those are all the ones with just Barbara and not Al in them. And then I could get rid of Barbara and Al, and I would have Carl, Dale, and Ernie. So these are all the groupings. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's only 10 possibilities for this one. Or groups. So you can see that when we had president, vice president, secretary, that is going to definitely give you more than just the groups of people where the order didn't matter. So when order matters, you're going to get more. And when the order doesn't matter, such as this grouping, it's called a combination. And so what a combination is, it's an arrangement of objects, again, numbers, letters, or people. So the definition starts out the same exact way as a permutation. And actually, there's one other key important piece of a combination that is very similar to a permutation, is that you cannot repeat objects. So again, as of right now, this is the exact same definition as a permutation. But the main difference and the difference between a permutation and a combination is that for a combination, order does not matter. Where in a permutation, the order mattered. For a combination, the order does not matter. Again, it doesn't matter whether we do Al, Barbara, Carl, or Carl, Barbara, Al. They're still in the group. So that's just one possibility. Where here, Al, Barbara, Carl would be different than Carl, Barbara, Al. That's why there's more in the president, vice president, secretary. So there is only one way to solve a combination. In permutations, we had the two ways, the decision chart and the formula. For combination, we have just the formula. So the formula is now NCR. So C is combination, N is still your total number of objects, R is still your number chosen, just like the permutation. And so now it's going to be N factorial divided by N minus R factorial. So again, right there, that's the permutation formula. But since combinations always have less, and the order does not matter, to get kind of rid of that repeating of Al, Barbara, Carl being the same as Carl, Barbara, Al in combinations, we divide, or in our denominator, we multiply by R factorial as well. So we're dividing by a larger number, which is always going to make it less than the permutations. And so a little note here, combinations will always have less ways than permutations. So now it says Felicia decides she wants to volunteer as well. How many different possibilities of officers are there now? So now, instead of having just 5 people go for president, vice president, secretary, we have Felicia in there, so now we have 6. So it's still president, vice president, secretary, but now there's 6 people that could be president, 5 people for vice, and then 4 people for secretary. So if we do 6 times 5 times 4, we get 120. If we now look at it, Felicia in the mix for the governing committees, now we're going to do, again, a combination. So now it would be 6C3, because we're still choosing 3, which is going to be 6 factorial divided by 6 minus 3 factorial times 3 factorial. So that gives us 6 times 5 times 4 times 3 times 2 times 1 over 6 minus 3 is 3. So I get 3 factorial, which is 3 times 2 times 1, times the additional 3 times 2 times 1. And now we can simplify. So 3's cancel, 2's cancel, 1's cancel. 3 times 2 is 6, cancels with that 6. So we have 5 times 4 left, which is 20 different ways. 20 different combinations, or wait, we can do that. Going to the next page. So since there are more volunteers, the Spirit Committee has decided to appoint another committee member. If they add a treasurer to the list, how many ways are there to select 4 officers now? So again, now we have 6 people with 4 offices, and we have 4 people to choose from when we're doing president, vice president, secretary, so therefore the order is mattering. So I can do a decision chart. So I can do 6 times 5 times 4 times 3. And that would give us 6 times 5 times 4 times 3, 360 ways that we could do officer positions when there's 4 spots available. And if it's governing committee now having 4 people instead, again, the order doesn't matter for that governing committee. So now we would be doing 6C4. And so we would be doing 6 factorial divided by 6 minus 4 factorial times 4 factorial. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Six minus 4 is 2, 2 factorial times 4 factorial. And so we would have here 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 4 times 3 times 2 times 1. So 4, 3, 2, 1's cancel. 2 would cancel or reduce with the 6. We'd have 3. So 3 times 5 is 15. So there's only 15 ways to do this. Now, good thing, that's still a lot of work there. We're using that formula even. So the good news is that we can do this on our calculator. And so to do combinations or permutations for that matter on our calculator, we are going to go in the same menu where we found the factorial. So if I'm going to do 6C4 on my calculator, I press the 6 first. I press the math button, which again, math is right here underneath the alpha. I scroll over to the probability, and then I see NPR and NCR. So I could also do permutations using the formula on the calculator. In this case, we were doing combinations, so I'll press 3. And again, we were choosing 4, so I push the 4 after that, and I get 15. So honestly, you don't necessarily need to use this formula. If on your test you write 6C4, type 6C4 in your calculator and get 15, that's all you need to do. And so again, we'll kind of show you how to do it for these next couple examples. For example 2, it says in one state lottery there are 56 numbers to choose from. How many ways are there to choose 6 of the 56 numbers? How many combinations of 6 numbers can be chosen from the list of 56? Does the order in which the numbers are chosen matter? So when you win a lottery, if you have your 6 numbers, it doesn't matter the order. You get the 6 numbers, you win. So it says find the number of possible combinations for the lottery. So this is a combination because the order doesn't matter, and we're not repeating because there's just those numbers in there and the balls jump out. So we would have 56 as our N. We would do C for a combination because the order doesn't matter, and we're choosing 6. So this is what I would expect you to write on your work. We can then go to our calculator, type 56 first, math, go to probability, C6, so 56 C6, and we get 3, 2, 4, 6, 8, 4, 3, 6. So 32,468,436 ways that you could win that possibilities of numbers there. So it says, what's the probability of selecting a winning number? So if you only buy one lottery ticket, well, your probability is 1 over 32,468,436, which is very, 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 very small probability. All right, and then in the game of poker called 5-card draw, each player is dealt 5 cards from a standard deck of 52 cards. While the players tend to arrange the cards in their hands, the order in which they get them does not matter. How many 5-card hands are possible? So again, when you play cards, you get the cards, but then the first thing most people do is arrange them in some other order. Some people do like smallest to largest, some people do largest to smallest, some people group the cards together. But you arrange them in some way. So that means that this playing cards is a combination because the order in which you get those cards does not matter. So we don't know how many 5-card hands are possible. So we have 52 cards to choose from. It's a combination because order doesn't matter and there's only one of each card. And we are choosing 5 of them. So we're doing 52 C5. Which is 2598960. So 2,598,960 ways that you could deal 5 different cards. All right, that's our combinations.